Hello everyone, this is Sagar Pandey from VIT University. So in this video we will be looking up upon the module 4 to 8 implementation of the software called Nand to Tetris. So in the first video we have seen the implementation of the first four modules including which included the implementation of XOR gate, the half adder, the full adder and the multiplexer. So in this particular video we'll be looking upon the assembler, the CPU emulator and the virtual machine emulator. So in order to run the CPU emulator, just go to the folder for Nand Tetris. In that, go to the tools folder, and there is a bash file named as CPU emulator. Just run that one. So the file is runnable, and yeah. So let me first explain the what are the different sections stand for. This is the ROM, read-only memory. This is the section where the actual code we have written will be displayed over here. The RAM is the random access memory and is the real-time memory that if we enter a value like 50, so it will be entered over here. This is the arithmetic and logic unit. So this is the basically the brain of the CPU. So we enter the inputs in like D input and the M/A input, and ALU will be performing some of the mathematical calculations and logical calculations. So and give the ALU output. So let's first load the program. Say this one. So here the program has been loaded, and you can see in the ROM part the assembly level code is displayed. So the main function of this particular code is to like print a rectangle of specified length in pixels. So like if we enter the length in pixel to be 50 for example, and just set it to fast the pace and just run the first step. Yeah, you can see from here the ALU is performing the work. If we have received the D input as 0 and the M/A input as 23 and the specified and work is the D, we get the output of ALU as 0. So in this particular code, the ALU has the function of the multiplexer. Like if we have specified the D to be the output, then it will give the D. If we move to the next step, we have like if we move to the fast pace, yeah. So we have the RAM input as 50. So this means the rectangle that should be appearing over here should be of 16 pixel width and 50 pixel depth. So if we run the particular steps, we get, yeah. So when we have the D input as 0 and the M/A input as 50 and the ALU is doing the part of the multiplexer, and we have to select the M, so the M should be the ALU output. So if we just fast forward the execution, you start getting, yeah, you see here we start getting a rectangle of 16 pixel width, and the program will stop when the depth of the rectangle is reached 50 pixels. So the end of the program should be of like yeah, we have reached the end of program. You can see the infinite loop, that it has entered an infinite loop. So since we didn't want this white space, this rectangle to again to be vanished after the execution, we ran into the infinite loop so that the rectangle stays on the white screen. So this was the example of the CPU emulator. The next we're going to do is the VM emulator. So now we move on to the virtual machine emulator. So in the tools folder you will also get a bash file with the name of VM emulator. Just run that one. It will open up a dialog box like this. So this is the virtual machine emulator. This is the actual location where we test the functioning of what the code we have written. All combined codes we judge over here. So let's first enter the Tetris part. Just load the complete folder. Yes, yeah. So this is the program code lines that we have written. So this is in the machine language. So when we run the code, just do it in the, just let me just remove the animations so that it becomes a quite bit easier. So once I click this run button, so it should replicate the function of the Tetris game that we used to play in the old days. This code has a little bit of error, as it would not perfectly replicate the functionality of the Tetris game, but still the falling of the Tetris blocks is visible with this code. So you can see the falling blocks of Tetris with this code. Yeah. So now you have seen the Tetris game functionality. Now we shall move to the other game called the Space Invaders. So this was a repository on the Git I found. So it's a program that replicates the video game that we used to play in old days. Let's run it at the fast pace and remove the animations so it would save time. Yeah, you can see over here. So you can see the code has resulted into a playable game. So in this way, the Nand Tetris codes help us to implement the fully runnable games like Tetris and this is Space Invaders with just using the NAND gates and some simple logic gates. So that's all for the Nand Tetris software. Thank you.